Imagine this. It's Thanksgiving Day, 1904. While most Americans are carving turkey and counting blessings, a desperate engineer named Benjamin Holt is about to test a machine that looks absolutely ridiculous. It's a bizarre contraption with wooden tracks wrapped around wheels, cobbled together from spare parts and sheer desperation. His competitors are already laughing. His investors are losing patience. But what nobody knows, not even Holt himself, is that this awkward prototype will build the Panama Canal, win 2 world wars, and become so dominant that it will operate in 192 of 195 countries on Earth. This is the story of how a Thanksgiving experiment became an unstoppable giant that literally built modern civilization. Before we dive into this incredible journey, if you love stories about innovation, perseverance, and the machines that changed our world, you need to subscribe to Motor Chronicles right now. We uncover the untold stories behind the titans of industry, the real people, the real struggles, and the truth behind the brands that shaped everything around you. Hit that subscribe button because this story gets even more dramatic. Now, let me ask you something before we continue. Where are you watching this from? Are you seeing Caterpillar machines working in your city right now? Drop a comment and let me know which country you're in, because I guarantee Caterpillar has touched your life in ways you never realized. Your voice matters here. Let's roll back to Stockton, California, November 24th, 1904. Benjamin Holt is standing in a field, staring at a problem that has destroyed fortunes and broken countless engineers. The soft soil of California's San Joaquin Valley. His steam-powered tractors, massive, powerful beasts weighing several tons, keep sinking into the earth like ships into quicksand. Farmers can't work their land. Construction projects grind to catastrophic halts. The more powerful the engine, the heavier the machine, and the deeper it sinks. It's a vicious cycle that seems fundamentally unsolvable. Traditional wheels simply spread weight over too small an area, creating pressure that soft soil cannot support. Every attempt to make tractors more powerful only made them more useless. But Holt had an idea that everyone thought was insane. What if, instead of wheels, he wrapped tracks around the wheels, creating a continuous moving platform that would distribute the machine's weight over a much larger surface area? The concept wasn't entirely new. There had been experiments with tracked vehicles before, crude attempts that mostly failed. But Holt was determined to make it work at scale, to create a practical machine that could operate in conditions where wheeled vehicles became helpless prisoners of the earth. His company, the Holt Manufacturing Company, had been building steam-powered agricultural equipment since 1883. But this was different. This was a gamble that could either save the company or become the most expensive mistake of his life. The machine that rolled out for testing on that Thanksgiving Day was designated number 77. It looked like something out of a fever dream. A steam tractor with wooden planks bolted together and wrapped around the wheels in an endless loop. The tracks were made from wooden slats connected by steel links, crude by any standard but revolutionary in concept. Holt's team had worked for months on this prototype, burning through capital that the company could barely afford to lose. The pressure was immense. If this test failed, investors would walk away, workers would lose their jobs, and Benjamin Holt's reputation would be demolished. Everything rode on whether this absurd-looking contraption could do what traditional tractors could not: move forward without sinking. Charles Clements, a photographer Holt had hired to document the test, set up his large-format camera to capture the moment. Photography in 1904 was nothing like today. It required enormous cameras, glass plates, and the photographer working under a dark cloth to compose the image. Clements positioned himself carefully, knowing that if this machine worked, he would be documenting history. If it failed, well, at least he would have captured an expensive disaster for posterity. The air was cold, typical for late November in California's Central Valley. Steam hissed from the tractor's boiler. Workers stood at a distance, some skeptical, some hopeful, all of them aware that their jobs depended on the next few minutes. Holt gave the signal. The engine roared to life, steam pressure building, and the operator engaged the drive mechanism. The tracks began to move, the wooden slats clicking rhythmically as they rotated around the wheels. And then, impossibly, miraculously, the machine began to move forward. Not just inching along, but actually crawling across the soft ground that had swallowed every other tractor. The tracks distributed the weight so effectively that the pressure on any given point of soil was dramatically reduced. Number 77 moved steadily, confidently, conquering terrain that had been unconquerable just moments before. It worked. Against all odds, against all skepticism, it actually worked. Charles Clements captured the moment through his camera, but when he looked at the image on his focusing screen, which showed an inverted, upside-down view as all cameras of that era did, he saw something remarkable. The way the tracks moved, the undulating motion as they rolled over the ground, reminded him of something alive. The machine wasn't just crawling, it was moving like a creature. He looked up from his camera and said words that would echo through more than a century of industrial history. "If that don't look like a caterpillar crawling along the ground, I don't know what does." And just like that, a name was born. Not from a corporate marketing department, not from some carefully crafted branding strategy, but from a photographer's spontaneous observation, spoken in the excitement of witnessing something revolutionary. Benjamin Holt immediately recognized the perfection of the name. Caterpillar captured exactly what the machine did. It crawled over obstacles, moved with a distinctive undulating motion, and conquered terrain where other machines failed. It was memorable, visual, and unlike any other name in industrial equipment. Holt trademarked the name, and within months, the Holt Caterpillar tractor became the official product designation. But here's what makes this story even more incredible. That Thanksgiving test wasn't just the birth of a product. It was the beginning of a revolution that would reshape the entire world. Those tracks that Benjamin Holt perfected would build the Panama Canal, moving more earth than any project in human history. They would cross the battlefields of World War I, where tracked vehicles became the first tanks, breaking the stalemate of trench warfare. They would construct the roads, the dams, the airports, the cities that define modern civilization. Every major construction project for the next century would depend on descendants of that crude wooden tracked machine that crawled across a California field on Thanksgiving Day, 1904. The irony is almost poetic. Benjamin Holt was trying to solve a local problem, how to make tractors work in soft California soil. He had no grand vision of global domination, no dream of building an empire that would span every continent. He was just an engineer who refused to accept that the problem was unsolvable. But that refusal, that stubborn determination to make tracks work when everyone else said it was impossible, created a company that would become synonymous with construction and earth-moving worldwide. The name given spontaneously by a photographer capturing an inverted image would become one of the most recognized and valuable brands on Earth. And the story doesn't end there, not even close, because what happened after that Thanksgiving success, the battles, the rivalries, the wars, and the ultimate triumph, is even more dramatic than anyone could have imagined. The caterpillar that Charles Clements named that day would grow into an unstoppable giant, and the journey from that crude prototype to global dominance is filled with conflict, innovation, and moments that changed history forever. Before that triumphant Thanksgiving Day test, before the name Caterpillar was ever spoken, there was failure. Catastrophic, expensive, humiliating failure. Benjamin Holt stood in California fields watching his machines. Machines he had poured his fortune and reputation into, sink helplessly into soft earth like dying animals. Each failure cost thousands of dollars. Each sinking tractor represented months of work, investor capital evaporating into mud, and the growing certainty that maybe, just maybe, the problem was actually unsolvable. This wasn't just an engineering challenge. This was an existential crisis that threatened to destroy everything Holt had built. To understand how revolutionary the Caterpillar tractor was, you need to understand just how desperate the situation had become by the turn of the 20th century. Agriculture in California's San Joaquin Valley should have been paradise. The soil was incredibly fertile, the climate was ideal, and the land stretched for hundreds of thousands of acres waiting to be cultivated. But there was one problem that made all of that potential worthless. The soil was too soft. Traditional farming equipment pulled by horses or oxen could barely function. When farmers tried to modernize with steam-powered tractors, the cutting-edge technology of the era, things got even worse. These machines were magnificent feats of engineering, with powerful engines and impressive capabilities, but they had one fatal flaw: they were incredibly heavy. A typical steam tractor in the early 1900s weighed anywhere from 10 to 20 tons. All of that weight was distributed over 4 relatively small wheels, creating immense pressure on whatever surface the wheels touched. On hard, dry ground, these machines were transformative, allowing farmers to plow faster and more efficiently than ever before. But on soft or wet soil, which described most of California's prime agricultural land, the wheels would sink. Not just a little. We're talking about wheels disappearing completely into the earth, tractors becoming immovably stuck, requiring teams of horses or other tractors to pull them out. Farmers who had invested their life savings in these modern machines watched them become expensive lawn ornaments, useless monuments to the limits of technology. Benjamin Holt understood the mathematics of the problem perfectly. He had been building steam tractors since the 1880s, and he was intimately familiar with every aspect of their design and operation. The issue was ground pressure, the weight of the machine divided by the surface area in contact with the ground. The heavier the machine and the smaller the contact area, the greater the pressure, and the deeper the machine would sink into soft soil. Traditional solutions didn't work. Making the wheels larger reduced pressure somewhat, but made the machines unwieldy and expensive. Adding more wheels helped marginally but increased mechanical complexity. Some engineers experimented with extremely wide wheels, but these created their own problems with turning and maneuverability. Every solution created new problems. Holt tried everything. He designed tractors with massive wheels 8 feet in diameter. He experimented with wheels that were 6 feet wide, looking more like something from a medieval siege weapon than a modern farm tractor. Some of these experimental designs worked marginally better than standard tractors, but none solved the fundamental problem. And all of them were expensive to build, difficult to maintain, and commercially impractical. Holt Manufacturing Company was bleeding money. Competitors mocked his failures. Daniel Best, his fiercest rival, was having similar problems but seemed to take satisfaction in Holt's struggles. The agricultural equipment industry was watching, waiting to see if Holt would give up or go bankrupt. The financial pressure was crushing. Holt had investors who expected returns. He had workers depending on their jobs. He had customers who had bought his tractors in good faith, expecting them to work, only to find them sinking into their fields. Some customers demanded refunds. Others sued. The company's reputation was being destroyed with every failed tractor. And the worst part was that Holt knew the problem was solvable, he just didn't know how. He would lie awake at night, his mind racing through possibilities, calculations, designs. His wife would find him sketching on whatever paper was available, trying different wheel configurations, different weight distributions, anything that might work. But here's what separated Benjamin Holt from the countless other engineers who gave up. He refused to accept that the problem was fundamentally unsolvable. While others concluded that heavy machinery and soft soil were simply incompatible, Holt became obsessed with finding a solution. He studied everything he could find about weight distribution, about how animals moved across soft ground, about historical attempts to solve similar problems. He learned that the Russian army had experimented with tracked sleds for moving artillery across snow. He read about Civil War-era attempts to create tracked vehicles, though most had failed. The concept of distributing weight over a continuous surface rather than discrete wheel contact points kept appearing in his research. The breakthrough idea came from pure desperation combined with systematic experimentation. What if, instead of trying to make better wheels, he eliminated the fundamental problem of wheels entirely? What if the machine rolled on a continuous track that wrapped around wheels, creating a much larger surface area in contact with the ground? The concept was elegant in theory. The same weight distributed over 10 or 20 feet of continuous track instead of over 4 small wheel contact patches would dramatically reduce ground pressure. But nobody had successfully built a practical tracked vehicle that could handle the power requirements and mechanical stresses of agricultural work. Holt began experimenting with tracks in secret, not wanting to reveal his ideas to competitors or alarm investors with yet another expensive experiment. His early prototypes were crude, wooden planks connected with chains, wrapping around modified wheels. They broke constantly. The tracks would slip off. The wooden planks would splinter under load. The connecting links would fail. Each failure taught him something, but progress was agonizingly slow and expensive. His chief engineer thought he was wasting time and money. Some workers quietly started looking for jobs with competitors, convinced the company was doomed. The pressure to show results was becoming unbearable. But Holt kept refining, kept testing, kept failing and learning. He reinforced the wooden planks with steel. He experimented with different track widths. He tried various methods of keeping the tracks aligned and preventing them from slipping off the wheels. He calculated and recalculated the weight distribution, the surface area, the ground pressure. On paper, it should work. The mathematics were sound. But paper doesn't sink into mud, and calculations don't break under load. He needed a working prototype, and the clock was ticking. The company couldn't survive much longer without a breakthrough. By late 1904, Holt was ready for a final test. He had poured everything into building prototype number 77, a steam tractor with experimental wooden tracks. If this failed, the company was likely finished. Investors would pull out. The bank would call in loans. Workers would lose their jobs. Holt's reputation would be destroyed, and he would be remembered as the engineer who couldn't solve an impossible problem. But if it worked, if those tracks could actually do what wheels could not, then everything would change. Not just for Holt Manufacturing Company, but for agriculture, for construction, for the entire industrial world. That's why Thanksgiving Day 1904 mattered so much. It wasn't just another test. It was the culmination of years of failure, desperation, and obsessive determination to solve a problem everyone else had given up on. When Benjamin Holt stood in that field watching number 77 prepare for its test, he was betting everything on one question. Could tracks succeed where wheels had failed? The answer would either save his company or bury it forever. And what happened next would change the world in ways that nobody standing in that field could have possibly imagined. The success of the Caterpillar tractor on Thanksgiving Day 1904 should have been Benjamin Holt's moment of triumph, the vindication of years of struggle and failure. But in the cutthroat world of agricultural equipment manufacturing, success didn't mean celebration. It meant war. Daniel Best, Holt's fiercest competitor and former business associate, had been watching closely. When news spread that Holt had successfully tested a track tractor, Best didn't congratulate him. He didn't acknowledge the innovation. Instead, he declared that he would build track tractors too, and he would build them better. What followed was one of the most intense rivalries in American industrial history, a battle that would reshape the entire industry and ultimately create the company we know today. To understand this rivalry, you need to know that Benjamin Holt and Daniel Best weren't just competitors, they had history. Both men had built their companies in California's agricultural heartland during the late 1800s. Both focused on steam-powered equipment for farming and logging. They knew each other personally, had competed for the same contracts, and had watched each other's successes and failures for decades. There was respect between them, but also deep animosity. Best was convinced that Holt had gotten lucky with the track design. Holt believed that Best was simply copying his innovation without doing the hard work of actual invention. The tension between them was personal, professional, and absolutely relentless. Daniel Best immediately began developing his own track tractors after Holt's successful test. He couldn't use the exact design, Holt was already filing patents, but the fundamental concept of continuous tracks couldn't be patented in isolation. Best hired engineers, built prototypes, and rushed to get his own track tractors to market. His company, the Daniel Best Agricultural Works, had financial resources that rivaled Holt's, and Best was determined to prove that he could build superior machines. The race was on, and both companies poured enormous resources into development, each trying to establish dominance in this revolutionary new technology. The patent battles began almost immediately. Holt filed patents covering various aspects of track design, track tensioning systems, and track drive mechanisms. Best filed his own patents claiming different innovations and improvements. Lawyers from both companies scrutinized every patent application, looking for ways to challenge or invalidate the other's claims. It was expensive, time-consuming, and bitter. Some patents were granted, others denied. Some overlapped in ways that created legal gray areas. Neither company could afford to lose these battles. Control of track technology meant control of the future agricultural equipment market. The stakes were existential. But the war wasn't just fought in courtrooms and patent offices. It was fought in farm fields, at agricultural shows, and in the court of public opinion. Both companies demonstrated their tractors at county fairs and agricultural exhibitions, each trying to prove their machines were superior. Holt's salesmen would disparage Best's tractors as poorly designed copies. Best's salesmen would claim that Holt's machines were unreliable and expensive. Farmers watched this rivalry play out, sometimes amused, sometimes frustrated that they had to navigate the competing claims and counterclaims just to buy equipment. The agricultural press covered the rivalry extensively, turning it into something of a spectator sport. The competition drove innovation at a breakneck pace. Holt improved his track design, moving from wooden tracks to steel tracks that were more durable and required less maintenance. Best responded with his own steel track designs, incorporating improvements based on field testing and customer feedback. Holt developed better tensioning systems to keep tracks tight and prevent slippage. Best created more efficient drive mechanisms. Each company's innovations forced the other to innovate faster. It was exhausting, expensive, and absolutely necessary. Falling behind meant losing market share, and losing market share meant potential bankruptcy. By 1908, both companies were producing track tractors commercially, and both were struggling financially. The development costs had been enormous. The patent battles were draining resources. The market for track tractors, while growing, wasn't expanding fast enough to support two major manufacturers both investing heavily in the technology. Dealers were caught in the middle, unsure which company to align with. Some carried both brands, but most were forced to choose, creating divided loyalties and market fragmentation. Industry observers began wondering whether both companies could survive this brutal competition. Then came a twist that nobody saw coming. In 1908, Daniel Best's son, Charles Best, had taken over day-to-day operations of the company as his father's health declined. Charles was pragmatic in ways his father sometimes wasn't. He looked at the financial reality. Two companies burning money fighting each other while the market wasn't growing fast enough to support both, and he made a controversial decision. He approached Benjamin Holt about selling the Daniel Best Company. The rivalry that had defined the industry for years might end not with one company destroying the other, but with a merger. Benjamin Holt was initially skeptical. This could be a trick, some kind of corporate espionage or manipulation. But as negotiations progressed, Holt realized that Charles Best was serious. The numbers were real, both companies were struggling, and consolidation made strategic sense. By combining forces, eliminating redundant operations, and pooling patents and technology, they could create a single dominant company that would control the track tractor market. The deal was completed in 1908, with Holt Manufacturing Company acquiring the Daniel Best Company. Daniel Best himself, the fierce rival who had pushed Holt to innovate faster and better than he might have otherwise, died shortly after, never seeing how the rivalry he had fought so hard would ultimately strengthen the very company he had competed against. The merger didn't immediately create the caterpillar we know today, that would come later, but it fundamentally changed the industry. Holt Manufacturing Company now controlled the vast majority of track tractor technology patents. They had eliminated their primary competitor. They had access to Best's dealer network and customer base. The combined company was positioned to dominate the emerging market for tracked equipment. But with dominance came new challenges. how to scale production, how to improve reliability, and how to find new markets beyond California agriculture. The company needed to grow or risk being overtaken by new competitors who were watching the track tractor market with great interest. The irony of this story is almost poetic. Benjamin Holt and Daniel Best spent years fighting each other, burning through capital, battling in courts, and trying to destroy each other's businesses. But that very competition, that brutal, expensive, relentless rivalry, forced both companies to innovate faster and better than they would have alone. The track tractors that emerged from this rivalry were far superior to what either company might have developed without the pressure of competition. And ultimately, the merger of these rivals created a company strong enough to survive the challenges ahead, including the massive opportunity that would define its future: the Panama Canal. The track wars taught Benjamin Holt something crucial. Innovation alone wasn't enough. You needed financial strength, you needed patent protection, you needed market dominance, and sometimes you needed to turn your fiercest enemy into your greatest asset. The company that would eventually become Caterpillar was forged in the fire of competition, strengthened by rivalry, and positioned for dominance through strategic consolidation. And the machines that emerged from these battles, refined through years of competing designs and improvements, were about to face their greatest test in the jungles of Panama, where they would prove their worth beyond anything anyone had imagined. The Panama Canal was supposed to be impossible. Not difficult, not challenging, impossible. The French had tried first, led by Ferdinand de Lesseps, the legendary engineer who had successfully built the Suez Canal. If anyone could cut a path through Panama, it should have been him. But Panama wasn't Egypt. Panama was a green hell of jungle, disease, landslides, and earth that seemed to fight back against every shovel, every machine, every human effort to control it. The French attempt, which began in 1881 with tremendous optimism and financial backing, collapsed into one of history's greatest engineering disasters. By 1889, after spending nearly $300 million and losing over 22,000 workers to yellow fever, malaria, and accidents, the project was abandoned. The equipment was left to rust in the jungle. The dream was declared dead. But America looked at that failure and saw opportunity. In 1904, the United States took over the project, driven by strategic necessity and national ambition. A canal connecting the Atlantic and Pacific Oceans would transform global trade, military strategy, and American power. President Theodore Roosevelt made it a priority, declaring that America would succeed where France had failed. But the engineers who arrived in Panama quickly discovered that optimism and national pride weren't enough. The challenges that had destroyed the French effort were still there, waiting. The Chagres River that flooded unpredictably, turning valleys into lakes and burying equipment in mud. The continental divide that required cutting through solid rock and unstable earth. The tropical diseases that killed workers faster than they could be replaced. And the sheer, overwhelming scale of moving 240 million cubic yards of earth, more than had been excavated in any project in human history. The chief engineer, John Stevens, understood something crucial. This wasn't just an engineering problem, it was an equipment problem. The French had used traditional excavation methods, manual labor, railroads, and steam shovels designed for stable ground. Those methods had failed catastrophically in Panama's conditions. The earth was unstable, prone to massive landslides that could bury an entire work site in minutes. The soil ranged from liquid mud that swallowed equipment to solid rock that dulled drill bits and broke machinery. The rain was relentless, turning excavation sites into swamps. Traditional wheeled equipment, the pride of American industrial might, became helpless prisoners of the mud, just like they had in California's fields. Stevens needed machines that could work in conditions that destroyed everything else. Word reached Stevens about a company in California that had developed tractors with continuous tracks that could operate in soft ground. The Holt Manufacturing Company had been selling their Caterpillar tractors to farmers and loggers, with growing success in difficult terrain. Stevens was skeptical. Agricultural equipment seemed unlikely to handle the brutal conditions of Panama, but he was also desperate. Traditional equipment was failing. The excavation schedule was already behind. Every day of delay cost thousands of dollars and risked the project's political support back in Washington. He needed to try something different, and these track tractors from California might be the answer. In 1907, Stevens ordered a trial shipment of Holt Caterpillar tractors to be sent to Panama. The tractors that arrived in Panama looked almost comical compared to the massive steam shovels and locomotives that dominated the work sites. They were smaller, simpler, and seemed inadequate for the monumental task ahead. Workers who had struggled for months with wheeled equipment that sank into the mud were openly skeptical that these tracked machines would perform any better. Some engineers thought Stevens had wasted money on an agricultural novelty that would fail just as spectacularly as everything else. But Stevens insisted on a proper test. The tractors were unloaded, fueled, and put to work in some of the worst conditions on the canal route. Areas where wheeled tractors had failed completely, where the mud was so soft that men walking would sink to their knees. What happened next shocked everyone. The Caterpillar tractors didn't sink. The continuous tracks distributed the weight so effectively that the machines crawled across mud that had been impassable to wheeled equipment. They could pull loads, operate excavation equipment, and move constantly without getting stuck. When landslides occurred, and they occurred frequently, sometimes moving thousands of tons of earth in seconds, the track tractors could work in the unstable aftermath, pulling equipment to safety and clearing debris. They operated in rain that turned work sites into swamps. They functioned in heat that caused other machines to overheat and fail. The tracks proved to be remarkably durable, handling the abuse of sharp rocks, sticky mud, and constant operation in ways that pneumatic tires or iron wheels could not. John Stevens immediately ordered more Caterpillar tractors. Not just a few more, dozens more. By 1908, Holt Manufacturing Company was shipping tractors to Panama as fast as they could build them. The company had to expand production capacity to meet the demand. Workers in California were building machines that would operate in conditions they had never imagined, in a jungle thousands of miles away, on the most ambitious engineering project in history. The canal project became Holt's largest single customer, providing revenue that stabilized the company financially and proved the value of tracked equipment on a global stage. It was the perfect testing ground. If Caterpillar tractors could work in Panama, they could work anywhere. The impact on the canal project was transformative. Areas that had been nearly impassable became workable. Equipment that had been stuck could be moved. The excavation rate increased dramatically because machines could operate in conditions that would have halted work previously. The track tractors pulled rail cars loaded with excavated earth, operated alongside steam shovels, and provided the mobility and reliability that the project desperately needed. Engineers began designing work processes around the capabilities of tracked equipment, using them in ways that hadn't been possible with wheeled machines. The Panama Canal was still an incredibly difficult project, but the Caterpillar tractors had solved one of the most fundamental problems: how to move heavy equipment through impossible terrain. By the time the canal was completed in 1914, 77 Caterpillar tractors had worked on the project, a number that seemed almost prophetic, matching the designation of that first successful prototype, number 77, that had been tested on Thanksgiving Day 1904. Those 77 machines had helped move more earth than the construction of the Great Pyramids, the Great Wall of China, and all major construction projects of the ancient world combined. They had operated in conditions that destroyed lesser equipment. They had proven that tracked vehicles weren't just useful for California farms. They were essential for the most demanding work environments on Earth. The Panama Canal wasn't just a triumph of American engineering. It was a triumph for Caterpillar, validating the technology in the most public and dramatic way possible. The success in Panama changed everything for Holt Manufacturing Company. The company was no longer just an agricultural equipment manufacturer serving California farmers. It was now proven on the global stage, with equipment that had conquered one of humanity's greatest engineering challenges. Orders began coming from around the world. Mining companies wanted tracked equipment for their operations. Logging companies needed machines that could work in forests and mountains. Military engineers started paying attention, recognizing that equipment capable of working in Panama's jungles might be invaluable in warfare. The Panama Canal was the proof of concept that launched Caterpillar toward global dominance, And the timing couldn't have been better, because within a few years, the world would descend into a war that would require tracked vehicles in quantities nobody had imagined. 77 Caterpillar tractors descended upon Panama between 1907 and 1914, and what they accomplished in those 7 years transcended mere construction. It was the conquest of itself. These machines, born from California mud and refined through corporate warfare, were about to prove their worth in the most hostile environment on Earth. The Panama Canal project wasn't just digging a ditch between two oceans. It was warfare against the jungle, against disease, against Earth that moved like liquid and rock that shattered steel. And the Caterpillar tractors became the iron shock troops in humanity's most ambitious engineering battle, working in conditions that would have seemed like fiction just decades earlier. The reality of working in Panama was beyond anything the machine's designers had imagined. The heat was suffocating, regularly exceeding 100 degrees Fahrenheit with humidity that made every breath feel like drowning. The rain came in torrential sheets that could dump several inches in hours, turning excavation sites into lakes and solid ground into quicksand. The Culebra Cut, the most challenging section of the canal, where they had to slice through the continental divide, was a living nightmare of unstable earth. Landslides were constant, sometimes moving millions of tons of earth without warning, burying equipment, destroying months of work, and occasionally killing workers who couldn't escape fast enough. This was where the Caterpillar tractors proved their worth most dramatically. Traditional wheeled equipment had been utterly defeated by these conditions. Steam locomotives, the backbone of industrial transportation, could only operate on carefully maintained rails that landslides destroyed constantly. Wheeled tractors and trucks sank helplessly into mud or became trapped when the ground shifted beneath them. Workers watched in frustration as expensive equipment became useless, stuck in place while the excavation schedule fell further behind. But the Caterpillar tractors, with their continuous tracks distributing weight over enormous surface areas, could operate where nothing else could move. They crawled across mud that would swallow a man to his waist. They navigated slopes that would tip over wheeled vehicles. They worked in conditions that seemed designed specifically to destroy machinery. The versatility of the track design revealed itself in unexpected ways throughout the project. Caterpillar tractors pulled trains of rail cars loaded with excavated earth, replacing multiple locomotives in areas where rail couldn't be reliably maintained. They operated steam shovels and excavation equipment, providing stable platforms in unstable ground. When landslides occurred and the Culebra Cut experienced major slides almost monthly, the tractors were the first machines that could safely enter the affected area, pulling buried equipment to safety and clearing debris before the next slide hit. Engineers began designing entire work processes around what the Caterpillar tractors could do, creating excavation strategies that would have been impossible with wheeled equipment. The machines operated with a reliability that shocked everyone familiar with the harsh conditions. Early concerns that the tracks would fail in Panama's mud and heat proved unfounded. The tracks were remarkably durable, able to handle sharp volcanic rock, sticky clay, and constant immersion in water. The engines, though working much harder in the tropical heat than they would in California, proved robust enough to operate for months with minimal maintenance. Workers developed deep respect for the machines, giving them names and treating them almost like living things. Some operators claimed their Caterpillar could sense unstable ground and would hesitate before crossing areas that later collapsed. Whether superstition or acute observation, the bond between operators and machines became legendary among canal workers. But the contribution of Caterpillar tractors went beyond just moving earth. The machines transformed the logistics of the entire project. Supplies needed to be moved constantly: fuel, spare parts, food, medicine, construction materials. Traditional transport methods were unreliable in Panama's conditions. Caterpillar tractors became the backbone of supply operations, pulling loaded sledges and trailers across terrain that isolated work camps from supply depots. This reliability in supply operations may have saved as many lives as the medical advances that conquered yellow fever and malaria. Workers who had adequate food, clean water, and medical supplies stayed healthier and could work more effectively. The tractors weren't just construction equipment, they were lifelines. The scale of earth moved by these 77 machines is difficult to comprehend even today. Conservative estimates suggest that Caterpillar tractors were directly involved in moving over 30 million cubic yards of earth, roughly equivalent to building 12 Great Pyramids of Giza. They operated in 3 shifts around the clock, with different crews maintaining 24-hour operations. Some individual tractors logged over 10,000 hours of operation during the canal project, running almost continuously for years. The wear and tear was enormous, but Holt Manufacturing Company had established a supply and maintenance network that kept the machines running. Spare parts were shipped constantly from California. Mechanics trained specifically on Caterpillar equipment were stationed in Panama to perform repairs and maintenance. The Panama Canal opened to traffic on August 15, 1914, just weeks after World War I began in Europe. The timing was extraordinary. The project that proved tracked vehicles could handle the most demanding conditions imaginable finished just as global conflict was about to demonstrate another crucial application for track technology. Military observers from several nations had visited the Panama Canal during construction, ostensibly to study the engineering techniques, but actually watching the Caterpillar tractors with great interest. The ability to move heavy equipment across difficult terrain without roads had obvious military applications. Several European armies had already begun experimenting with tracked vehicles for artillery transport and supply operations. The war would accelerate that experimentation into something far more dramatic. For Holt Manufacturing Company, Panama was more than just a lucrative contract. It was proof of concept on the grandest possible stage. The company had demonstrated that tracked vehicles weren't just agricultural curiosities or niche equipment for specific conditions. They were transformative technology capable of accomplishing tasks impossible for wheeled vehicles. Orders flooded in from mining operations in South America, from logging companies in the Pacific Northwest, from construction projects around the world. The Caterpillar brand, named spontaneously by a photographer just 10 years earlier, was becoming synonymous with reliability in impossible conditions. The machines that conquered Panama were about to conquer the world. But perhaps the most profound impact of the Panama Canal experience was what it taught the company about their own product. Engineers learned that tracks could be made stronger and more durable. They discovered that engines needed better cooling systems for tropical operations. They found that operator comfort mattered. Exhausted operators made mistakes that damaged equipment or endangered lives. Every lesson learned in Panama's jungles was incorporated into the next generation of Caterpillar tractors, making them better, more reliable, and more capable. The canal was a 7-year testing ground that cost other companies nothing but taught Holt everything about building the world's best tracked vehicles. And that knowledge was about to become extraordinarily valuable as the world descended into industrial warfare. The Panama Canal had barely opened when Europe exploded into the most devastating war humanity had ever seen. World War I began in August 1914, and within months, it became clear that this wasn't warfare as anyone had known it. Armies dug trenches across France and Belgium, creating a static, murderous stalemate where millions of men died for yards of mud. Artillery bombardments churned battlefields into lunar landscapes where nothing could move. Traditional cavalry charges became suicide missions against machine gun fire. Military commanders desperately needed something that could cross no man's land, survive artillery, and break the deadlock that was consuming an entire generation. They needed tracked vehicles. They needed what Caterpillar had perfected in Panama's jungles. The British developed the first tanks, rolling them onto battlefields in 1916 with mixed success. These early tanks were crude, unreliable, and frequently broke down. But they proved the concept. Tracked vehicles could cross trenches, crush barbed wire, and provide mobile protection for infantry. The problem was that nobody really knew how to build reliable tracked vehicles at scale. Nobody except the Holt Manufacturing Company, which had been perfecting the technology for over a decade. Military engineers from Britain, France, and America visited Holt's California facilities, studying the Caterpillar tractors and learning everything they could about track design, suspension systems, and powertrains. The agricultural tractors that had conquered Panama were about to become templates for weapons of war. When America entered World War I in 1917, the military demand for tracked vehicles exploded. The Army needed tractors to pull artillery across muddy battlefields. They needed tracked vehicles to haul supplies where trucks and wagons couldn't operate. They needed the reliability and terrain capability that only Caterpillar could provide. Holt Manufacturing Company received massive government contracts, orders that dwarfed anything from the agricultural or construction markets. The company had to dramatically expand production, hiring hundreds of new workers, building new facilities, and operating around the clock to meet military demand. The war was transforming Caterpillar from a specialized equipment manufacturer into an industrial powerhouse. But World War I ended in 1918, and with it came the inevitable question: what happens to a company that had geared up for wartime production when peace arrives? Many military contractors faced bankruptcy as orders evaporated and facilities sat idle. Holt Manufacturing Company avoided that fate through strategic vision and perfect timing. In 1925, the company merged with its former rival successor, the C.L. Best Tractor Company, ironically, run by Clarence Best, son of Daniel Best, reviving the family rivalry in a new generation. The merger created the Caterpillar Tractor Company, combining the strengths of both companies and creating an entity with the scale and resources to dominate the global market. The iconic name, born from a photographer's observation 21 years earlier, became the official company name. The 1920s and 30s saw Caterpillar expand aggressively into civilian markets. The company's tractors built roads across America, constructed dams like the Hoover Dam, cleared forests, worked in mines, and became essential to every major infrastructure project. The distinctive yellow color, officially called highway yellow, became synonymous with heavy construction. Caterpillar established dealer networks around the world, creating service and support infrastructure that ensured their machines could be maintained anywhere. The company that had started with solving California farm problems was now a global enterprise with operations on every continent. But the expansion was interrupted dramatically when the world descended into an even more devastating conflict. World War II transformed Caterpillar into something unprecedented, a company upon which victory itself depended. The scale of the war demanded earth-moving and construction capabilities that exceeded anything in World War I by orders of magnitude. Armies needed roads built across deserts, jungles, and mountains. Airfields had to be constructed on Pacific islands and in North Africa. Supply lines stretched across continents, requiring infrastructure that didn't exist. The military demand for Caterpillar equipment was so intense that the company received official priority for raw materials, labor, and transportation. Caterpillar wasn't just supporting the war effort, it was critical infrastructure for the Allied war machine. The statistics are staggering. During World War II, Caterpillar produced over 51,000 tractors and engines for military use. These machines built the Burma Road, a supply route through impossible terrain that kept China in the war. They constructed airfields across the Pacific from which B-29 bombers would eventually strike Japan. They built the Alaska Highway 1,600 miles through wilderness in less than a year. Caterpillar equipment cleared North African deserts for tank battles, built roads through Italian mountains, and prepared French beaches for the D-Day invasion. General Dwight Eisenhower later said that the Allies won World War II on the strength of American production capacity, and Caterpillar was a crucial part of that capacity. Without tracked vehicles that could work anywhere, build anything, and keep operating under impossible conditions, the war would have been immeasurably harder, perhaps impossible, to win. But here's the uncomfortable truth that the company's official histories tend to minimize. War was extraordinarily profitable for Caterpillar. The massive government contracts, the priority access to materials and labor, the guarantee that every machine produced would be purchased. This created unprecedented growth and profitability. The company expanded facilities, improved production techniques, and built financial reserves that would fuel post-war dominance. Caterpillar's success was built on the most devastating conflict in human history, on contracts paid for by taxpayers, on equipment that enabled battles where millions died. This isn't to suggest anything unethical. The company produced equipment the military desperately needed, But the reality is that global warfare transformed Caterpillar from a large company into an unstoppable empire. When World War II ended in 1945, Caterpillar faced the same question that had challenged them after World War I. Could they sustain their growth when military contracts ended? But this time, the answer was dramatically different. The post-war world needed rebuilding on a scale never before attempted. Europe was in ruins. Japan's cities were destroyed. Infrastructure across Asia, Africa, and Latin America needed modernization. The Marshall Plan and similar reconstruction efforts required earth-moving equipment in quantities that made wartime production look modest. Every destroyed city that needed rebuilding, every new highway system, every dam and airport and industrial facility, they all needed Caterpillar equipment. The company that had prepared for potential decline instead found itself facing unlimited demand. The war had also given Caterpillar something invaluable: a global reputation for reliability under the worst possible conditions. Military engineers and construction battalions who had used Caterpillar equipment during the war became the post-war generation of construction managers and project engineers. They specified Caterpillar equipment because they knew it worked. They trusted the brand because they had seen the machines operate in combat zones, in jungles, in deserts, under conditions where failure meant lives lost. That trust, earned through wartime performance, became the foundation for decades of commercial dominance. Competitors could build track tractors, several tried, but none had the proven battlefield reliability that Caterpillar could claim. The transformation from Benjamin Holt's desperate Thanksgiving Day test in 1904 to global post-war dominance in 1945 was complete. The company had evolved from agricultural equipment manufacturer to construction industry leader to military contractor to global industrial empire. And the foundation of that empire was the continuous track technology that had been perfected through decades of competition, proven in Panama's jungles, refined through 2 world wars, and recognized worldwide as the standard for impossible conditions. The next phase of Caterpillar's story would see the company expand to dominance so complete that modern civilization became dependent on these yellow machines. Look around any major city in the world. Anywhere. London, Tokyo, Sao Paulo, Dubai, Mumbai, Lagos, it doesn't matter. If there's construction happening, if infrastructure is being built, if earth is being moved, you will see yellow machines with the Caterpillar name. This isn't coincidence. This isn't market preference. This is dominance so complete, so total, that modern civilization literally cannot function without these machines. Caterpillar operates in 192 of the world's 195 countries. The 3 countries without Caterpillar presence? North Korea, Cuba, and Syria. Nations so isolated from global commerce that they exist outside the normal economic system. Everywhere else, Caterpillar is there. And this unprecedented global domination didn't happen by accident. The foundation for this empire was built in the post-war reconstruction boom. Europe needed rebuilding after World War II's devastation, and the Marshall Plan poured billions of dollars into reconstruction projects. Every destroyed city, every bombed factory, every ruined road and bridge required heavy equipment to clear debris and rebuild. American companies, particularly Caterpillar, dominated this market because European manufacturers had been destroyed or crippled by the war. Caterpillar established dealerships across Western Europe, trained local mechanics and operators, and created supply chains that ensured parts and service were available anywhere reconstruction was happening. By the time European manufacturers recovered, Caterpillar had already established market dominance that would prove nearly impossible to break. But Europe was just the beginning. The 1950s and 60s saw massive infrastructure development across the developing world. Newly independent nations in Africa and Asia needed roads, dams, airports, and industrial facilities. The Cold War meant both the United States and Soviet Union were funding development projects to win allies and influence. Oil discoveries in the Middle East required massive construction of extraction, refining, and transportation infrastructure. Mining operations expanded across Latin America, Africa, and Australia, all requiring earth-moving equipment that could operate in remote locations with minimal support. Caterpillar positioned itself as the solution to all of these needs, establishing the global dealer network that became the company's most valuable asset. The dealer network was a brilliant strategy that competitors struggled to replicate. Caterpillar didn't just sell equipment. They created partnerships with local businesses who became exclusive dealers in their territories. These dealers invested in parts inventory, service facilities, and trained technicians. They understood local conditions, spoke local languages, and built relationships with construction companies and government agencies. When a mining company in Chile or a construction firm in Thailand needed equipment, they didn't just buy a Caterpillar machine, they bought into an entire support ecosystem. That ecosystem meant that even if a competitor's machine was slightly better or cheaper, switching away from Caterpillar meant abandoning reliable parts supply and service support. The switching costs were enormous. The product lineup expanded dramatically during this global growth phase. Caterpillar wasn't just building tractors anymore. They developed bulldozers, excavators, motor graders, scrapers, wool loaders, articulated trucks, and specialized equipment for mining, forestry, and marine applications. They built diesel engines that powered not just their own equipment but also generators, ships, and locomotives. They created hydraulic systems, undercarriage components, and attachments that turned their machines into versatile tools capable of countless tasks. Every product category they entered, they dominated through the same formula: reliability, dealer support, and the reputation earned over decades of proven performance. The yellow color became one of the most recognized brand identifiers on Earth. Caterpillar trademarked their distinctive highway yellow and defended it aggressively against imitators. The color wasn't just aesthetic, it served safety purposes, making machines highly visible on construction sites. But it also became a symbol of quality and capability. Construction managers who saw yellow machines knew they were looking at equipment that would work, that could be serviced anywhere, and that would retain resale value. The brand equity in that yellow color became so valuable that Caterpillar licensed it for merchandise, creating a secondary revenue stream from boots, apparel, and accessories that had nothing to do with heavy equipment but traded on the brand's reputation for toughness and reliability. The scale of Caterpillar's operations by the late 20th century was staggering. The company operated manufacturing facilities on 6 continents. They employed over 100,000 people directly, with hundreds of thousands more working for dealers and suppliers. Their annual revenue exceeded tens of billions of dollars. They were producing thousands of machines annually, from small compact excavators to mining trucks the size of houses that could haul 400 tons in a single load. The technology had evolved dramatically from Benjamin Holt's wooden-tracked prototype, incorporating computer controls, GPS guidance systems, and engine management software, but the fundamental concept remained: tracked vehicles that could work where nothing else could operate. But with dominance came scrutiny and criticism. Environmental activists targeted Caterpillar for enabling destructive mining and logging operations. Human rights organizations criticized the company when their equipment was used in controversial construction projects or military operations. Labor unions battled with management over wages and working conditions. Competitors filed antitrust complaints claiming Caterpillar used its market power anti-competitively. The company faced the reality that being everywhere, doing everything, meant being blamed for everything. Every dam that displaced communities, every mine that scarred landscapes, every road that cut through pristine wilderness. Caterpillar equipment was there, and critics held the company responsible. The financial crisis of 2008 hit Caterpillar hard, as construction and mining operations collapsed globally. Revenue and profits plummeted. The company laid off thousands of workers. Stock prices crashed. For the first time in decades, Caterpillar's dominance seemed vulnerable. Competitors sensed opportunity, and some gained market share during the downturn. But Caterpillar's fundamental strengths, the dealer network, the parts supply infrastructure, the brand reputation, proved resilient. When the global economy recovered, Caterpillar recovered faster and stronger than competitors, reasserting dominance across most product categories. The crisis had tested the empire and found it unbreakable. By the 21st century's second decade, Caterpillar faced new challenges from unexpected directions. Chinese manufacturers, supported by government subsidies and growing technical capabilities, began competing aggressively on price. Automation and autonomous vehicle technology threatened to transform the industry in ways that could disadvantage established players. Environmental regulations pushed toward electrification and alternative fuels, requiring massive research and development investments. Digital connectivity and data analytics were creating new business models that competed with traditional equipment sales. The industry that Caterpillar had dominated for a century was changing faster than ever before, and the company had to evolve or risk being disrupted by forces that didn't exist when they built their empire. Yet despite these challenges, Caterpillar's position remains remarkably strong. The company ranks among the most valuable brands globally, worth tens of billions of dollars in brand equity alone. Their dealer network, built over decades, remains an unmatched competitive advantage. Their installed base of machines creates ongoing demand for parts, service, and eventual replacements. They're investing billions in new technologies, from autonomous mining trucks to hybrid and electric machines. The yellow giants that built the Panama Canal, won 2 world wars, and constructed modern civilization aren't finished yet. They're adapting, evolving, and preparing to dominate the next century just as completely as they dominated the last one. 121 years after Benjamin Holt watched his crude wooden-tracked prototype crawl across California mud on Thanksgiving Day 1904, Caterpillar machines are building the future. Autonomous mining trucks the size of small houses operate in Australian mines without human drivers, guided by GPS and artificial intelligence. Electric excavators work in European cities, moving earth silently without the diesel roar that characterized construction for a century. Machines equipped with sensors and connectivity upload performance data in real time, predicting maintenance needs before failures occur. The technology would seem like magic to Benjamin Holt, but the fundamental mission remains identical: move earth, build infrastructure, and make the impossible possible. The journey from that first successful test to today's technological sophistication is more than just corporate history. It's the story of how human civilization transformed itself. Every road you drive on, every building you enter, every bridge you cross, every airport you fly from, all of it was built with equipment that traces its lineage back to that Thanksgiving Day breakthrough. The Panama Canal that connected oceans, the interstate highway system that unified continents, the dams that generate electricity and control floods, the mines that extract resources for modern technology, the ports that enable global trade. None of it would exist without the tracked vehicle technology that Benjamin Holt perfected through desperation and determination. Modern civilization is literally built on Caterpillar's foundation. But the legacy extends beyond just what the machines built. It's about what they proved was possible. Before Caterpillar, conventional wisdom said certain terrain was simply impassable, certain projects were impossible, certain challenges couldn't be overcome with existing technology. Benjamin Holt looked at that conventional wisdom and refused to accept it. He failed repeatedly, lost money, faced mockery and skepticism, but kept experimenting until he found a solution. That refusal to accept impossibility became embedded in the company's DNA. When engineers said the Panama Canal couldn't be built with available equipment, Caterpillar proved them wrong. When military planners said tracked vehicles couldn't handle battlefield conditions, Caterpillar demonstrated otherwise. Every impossible project for the past century has had the same answer: bring in the yellow machines. The name itself, Caterpillar, represents one of history's perfect accidents. Charles Clements could have said anything when he looked through his camera on that Thanksgiving Day. He could have described the machine in purely mechanical terms. He could have made no comment at all. But he saw something alive, something organic in how those tracks moved, and he gave it a name that perfectly captured both what it did and what it would become. A caterpillar is a creature that crawls over obstacles, transforms landscapes by its passage, and eventually becomes something that can fly. The metaphor was more perfect than anyone realized in 1904. The company that crawled through mud in California would eventually soar to global dominance, transforming everything it touched. The human story behind the machines deserves remembering. Benjamin Holt died in 1920, just 5 years before the company merger that would create Caterpillar Tractor Company. He didn't live to see his invention dominate global construction, win world wars, or become one of the most recognized brands on Earth. He died knowing he had solved an important problem and built a successful company, but probably not understanding the magnitude of what he had started. Daniel Best, his fierce rival, died in 1911, also before seeing how the rivalry he fought would ultimately strengthen the industry. These men were engineers first, businessmen second, and their obsession with solving technical problems created something far greater than they imagined. The workers who built these machines, the operators who drove them, the mechanics who maintained them, their stories are largely forgotten but equally important. The men who assembled the first track tractors in California workshops, the operators who guided Caterpillar machines through Panama's jungles, working in conditions that killed thousands, the mechanics who kept equipment running through 2 world wars, often under enemy fire, the dealers who built businesses around supporting these machines in every corner of the world, the engineers who continuously improved designs, making each generation more capable than the last. This is their legacy too, a century of skilled labor and expertise that transformed simple machines into civilization's essential tools. Today's Caterpillar faces challenges that would be unrecognizable to Benjamin Holt. Climate change demands reduced emissions and eventually zero-emission equipment. Automation threatens to eliminate the skilled operators who have been the company's customers for a century. Global competition from manufacturers who didn't exist 20 years ago challenges market share. Digital disruption creates new business models that compete with traditional equipment sales. The company must transform itself as dramatically as it has transformed the world, adapting to a future where the rules of construction and mining are being rewritten. But if history teaches anything, it's that betting against Caterpillar's ability to adapt and dominate is unwise. The autonomous mining trucks operating today in Australia and Chile represent the future taking shape. These machines, weighing 400 tons, capable of hauling hundreds of tons of ore, operating 24 hours a day without rest, navigate mine sites without human drivers. They're more efficient, safer, and more productive than human-operated equipment. Some mines now operate entire fleets autonomously, with human supervisors monitoring dozens of machines from control centers thousands of miles away. This isn't fiction. This is Caterpillar's present, and it's just the beginning. The company is developing autonomous construction equipment, electric machines, hydrogen fuel cell systems, and technologies that haven't been announced publicly. The next revolution in earthmoving is being built right now. But amidst all this innovation and technology, the fundamental truth remains. Caterpillar succeeds because it solves problems that others can't or won't solve. That was true in 1904 when Benjamin Holt needed tractors that wouldn't sink. It was true in 1907 when the Panama Canal needed equipment that could work in jungles. It was true in both world wars when militaries needed vehicles that could cross battlefields. It's true today as the world demands equipment that can build infrastructure while reducing environmental impact. The technology changes, the challenges evolve, but the mission stays constant. Make the impossible possible. If you've made it this far in this story, you understand something important about innovation, perseverance, and how individuals with vision can literally reshape the world. If these stories of engineering triumph, competitive battles, and technological revolution resonate with you, then you need to be part of the Motor Chronicles community. Subscribe now because we're uncovering the hidden histories of the machines and companies that built everything around you. The stories behind the brands, the real struggles, the truth that official histories often gloss over. That's what we do. Hit that subscribe button and join thousands of others who appreciate the remarkable human stories behind industrial giants. 121 years after that Thanksgiving test, the Caterpillar legacy continues. The machines are more sophisticated, the projects are more ambitious, and the challenges are different. But that photograph taken by Charles Clements, showing an awkward wooden-tracked machine crawling across California mud, still represents something profound. the moment when human determination conquered impossible terrain and started building the modern world. Benjamin Holt's refusal to accept that the problem was unsolvable changed everything. And every yellow machine working on every construction site in 192 countries carries forward that same spirit. There is no terrain too difficult, no project too ambitious, no challenge too great. That's the Caterpillar legacy, and it's still being written every day.